Hello students, in the today's lecture we will discuss the law of conservation of momentum, which is very important law, but it is excluded from our syllabus. Law of conservation of momentum. Law of conservation of momentum. What this law states? The law states when two or more bodies interact with each other, then vector sum of their momenta means it is plural of momentum. Momentum plural momenta. Vector sum of their momenta always remain constant. When two or more bodies interact with each other, then vector sum of their linear momenta remain constant. Only condition is there should not be external unbalanced force applied. External unbalanced force applied. This is the law of conservation of momentum. When there is no external unbalanced force, the vector sum of all the momentum is remain constant. Is remain constant. In other words, we can write in an isolated system, the total momenta remain constant. That is, the sum of momenta before collision is equal to sum of momenta after collision. If two bodies collide with each other, then the sum of momenta before collision is equal to sum of momenta after collision. This is the definition of the law of conservation of momentum. Now we will explain it mathematically. I will erase it. Let a body A of mass m1 moving with velocity u1. Another body b of mass m2 is moving with velocity u2, where u1 is greater than u2 in a straight line. If the velocity of a is greater than the velocity of b, then after some time it will collide with b. Let here a and b collide with each other. During collision, what happens? A will exert force on B, that is, force applied on B due to A. At the same time, according to Newton's third law of motion, body B will also exert force on the body A, which is equal in magnitude but opposite in direction, that is minus FAB. Force applied on A due to B. After the collision, what will happen? Their velocity will be changes. When force is applied, velocity changes. After collision, the velocity of body A changes to v1 and velocity of body B changes to v2. u1 changes to v1 and u2 changes to v2 due to the interaction between A and B. Due to interaction, both bodies apply force on each other. Now, during collision, A exerts a force on B that we represent by FBA. Due to reaction, B exerts a force on A that we represent by FAB, which is negative, opposite in a direction. After collision, u1 changes to v1 and u2 changes to v2. u2 changes to v2. Now, before collision, momentum of body A, momentum of A that we represent by PA. Momentum equal to mass into velocity. Mass of the body A is m1 and velocity of the body A is e1. Momentum of B PB equal to mass is m2 and velocity is u2. After collision, momentum of A, that we will represent PA dash M1 V1, momentum of B, that is PB dash equal to M2 V2. Now, the rate of change of momentum, the rate of change of momentum is force. We know from the second law, we know the rate of change of momentum is a force. That means the rate of change of momentum B is equal to force applied by A on B. The rate of change of momentum of B is equal to the force applied by A on B, that is FBA. So FBA is equal to final momentum PB dash minus PB by time t. PB dash equal to M2 V2 minus M2 U2 by t. M2 V2 minus M2 U2 by time t. If we take common M2, V2 minus U2 by t. Now, the rate of change of momentum of body A is equal to the force applied by B on A. Similarly, FAB equal to PA dash minus PA by T. What is the final velocity of body A? V1. Mass M1. M1 V1. Initial momentum M1 U1. By T. Take common M1, V1 minus U1 by T. Force applied on B due to A is equal to M2 into V2 minus U2 by T, and force applied on A due to B, M1 into V1 minus U1 by T. Now I will erase this side. I will write here. Newton's third law. Newton's third law we will apply here. Newton's third law states that to every action there is equal and opposite reaction. That means force applied on A due to B is equal to force applied on B due to A but in opposite direction. That means force applied on A due to B is equal to the negative of force applied on B due to A. What is FAB? Put here M1 into V1 minus U1 by T equal to FBA M2 V2 minus U2 by T. Now T cancel. M1 you will multiply it. M1 V1 minus M1 U1 equal to M2 V2 minus M2 U2. Here it is negative, na? That implies M1 V1 minus M1 E1 is equal to minus M2 V2 minus 1 minus plus M2 U2. Now, if I shift the position of minus M1 E1 to this side, it will be positive, and M2 V2 when come to this side, it also becomes positive. M1 V1 plus M2 V2 is equal to, when minus M1 E1 shifted to this side, it become positive M1 E1 plus M2 U2. From this, what do we know? The sum of linear momenta after collision is equal to the sum of linear momenta before collision. That means sum of linear momenta after collision is equal to sum of linear momenta before collision. So, law of conservation of momentum, now it is proved. Now we will apply law of conservation momentum for the recoil of gun. From law of conservation momentum, M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. That means sum of linear momenta before collision is equal to sum of linear momenta after collision. Before firing, what is the velocity of a bullet? 0. What is the velocity of a gun? 0. Let the mass of bullet M1 before firing, velocity U1 equal to 0. We will take mass of gun M2 and before firing velocity U2 equal to 0. Total momenta before collision or before firing. Before firing. M1 U1 মানে M1 into 0 plus M2 into 0, that equals 0. After firing, let the velocity of bullet V1, velocity of bullet V1, and recoil velocity of gun equal to V2. According, if we put here sum of momenta after firing, this velocity is minus V2 in the backward direction. M1 V1 plus M2 into minus V2. According to the law of conservation momentum, momenta before collision, before firing is equal to momenta after firing. So 0 is equal to M1 V1 plus M2 into minus V2. Why I take here negative? Because it is in the opposite direction. This velocity is in the opposite direction of the bullet. Or minus M1 V1 plus and minus M2 V2. Or M1 V1 equal to M2 V2. From this, we can find V1 is equal to M2 V2 by M1 and V2 is equal to M1 V1 by M2. We can find the velocity of a bullet and velocity of a gun. The numericals based on this, law of conservation of momentum, Newton's second law of motion, we will discuss in the next videos. If you like my teaching, then you like, share and subscribe it so that I will be inspired and I will make more and more videos. And that is also beneficial for other students, those who are required. Thank you.